Okay, so in this lesson I'm going to look at using Excel to go through some iterations of Newton's method using this function and this initial guess. So I'm going to start by just putting my initial guess up here in the top left hand corner. That's 2. Okay, and the next thing I'm going to put in my function here. Now my function was 1 minus x times e to the power of x. So I'm going into Excel. I'm going to hit equals, and this just defines this cell. I'm going to put in 1 minus x is just this value in here, multiplied by e to the power of. To put in e to the power of in Excel, I have to type in exp. I'm just going to click on that, double click, and it gives me that. So that says e to the power of, and I'm going to put in that number in there as well. And hit enter. So that's 1 minus x times e to the power of x. Okay. The second thing I'm going to put in is the derivative, which is negative e to the power of x times x plus 1. I'm going to put that in here. Negative e to the power of x times, I think it was x plus 1. And again, x is just that number 2 plus 1. And close bracket. Okay, and in here, I'm just going to put equals. Okay, now what's it equal to? It's equal to my first guess, which is that, minus the function evaluated at 2, which is that, divided by the derivative evaluated at 2, which is that. And I'm going to hit enter. And that's 1.378. You can see that's the value, hopefully, I got down here. I've rounded it off, but it's that value in there. That's my first iteration. To look at loads of iterations, all I do is highlight these 3 cells. I'm going to just drag this down here, and that will give me better and better and better approximations. Okay, so something like that. Okay, so 1.378445, that's my first iteration. My second one, 0.904827. You can see over here at 0. Because I had introduced rounding here, that introduced a little bit of error, so I'm not getting 0.904, I'm getting 0.906. But, you know, without the rounding, I would get the same stuff. This is getting closer and closer. And you can see here as I go down and down, let me round again, let me round off to a whole number of decimals. Let's pick, let's go up to 15 decimals, say. And let me drag this out here. And you can see the numbers here are getting these every second line. There's the numbers I'm talking about. There's these ones I'm talking about. So something like that. That's what we're talking about. So all I did was I highlighted these 3 values and just drag them down. Okay, this value, that's the approximation for the root. So highlight these 3 values, drag them down. You can see in yellow now, because I've put this cell in as yellow, all the yellows are the approximation. So once we get down here, 56714,329, that's really close. That's what it's saying is the root of the function. Okay. Now if I go into GeoGebra and I can put that function in there, and you can see there's the function. There's my root. Let me just put in the value of that root. Oh, it didn't come up. Try that again. Settings, show value. So it's 0.57. Again, I can just change the rounding option here to maybe 15 decimal places. And close that down. So there's my actual, you know, correct to 15 decimal place. 0.6557143289803278. My Excel 0.56714,329. As I keep going, and there's no limit on how far I can go with this with Excel, I can just drag, get further and further iterations all the way down. You know, just stop somewhere. this is where it's taking me to. Okay, so getting loads of iterations using Newton's method. That's how we use Excel to do it. Also, a bit of a shout out for GeoGebra. I can just put in any function. I just typed in to the input bar 1 minus x times e to the power of x. And there's my function. If GeoGebra draws the function, you can see there is the root where it cuts the x-axis. Okay.